Please tell me, what you know about the gases? Anybody?
Gases can change.
Gases, please. Whatever you know about the gases, you speak. What do you know about gases?
Easily.
So as we know that gases, if will come compared to the solids and liquids, the particles are very far each other or very closer each other compared to the liquids and solids. Communication is more important. Tamil Selvan. So if you observe in the gases, the particles are much further apart. Understanding means they are far each other. They are far each other compared to the solids and as well as liquids. So that is why the spaces between the particles of a gas are very, very large. So if we take the gas, the spaces between the particles is very, very large compared to the solids and as well as liquids. So that is why, as we know that the space is keep on increasing. So as we know, the force of attraction will decreases or increases. The force of attraction will decreases or increases. Yesterday only I have taught you, correct? At least one you will say I will satisfy. If the space is increasing, what will happen? The space between them is increasing. Then the force of attraction will be. Pradosh, what happened to the force of attraction? Nobody?
Hi, sir.
Hiya. What are you talking? So as we know that if it comes to the solids, the spaces between them is very, very less, so that they have strong attractive forces. As well as if it comes to the liquids, the spaces them is little bit more, so that they have understanding less force of attractions compared to the solids. As well as if it comes to the gases, they have a large spaces between the particles. If force is large, the distance is large, then what will happen? The force of attraction is very, very smaller. What is this, Manya? How many times I should say? But still you are like that. So the force of attraction is very, very less. Very, very less because they are present at large distance each other. So that is why we can say they have negligible forces. Understand? So the forces of attraction between the gaseous particles are negligible, so that only they can go. The particles of gas, they are free to move in any direction. So that is why always a gas should be stored in a closed container. Closed container, because the intermolecular forces is very, very small, negligible. So particles can escape in any directions. Understand, Amma? So that is the reason the positions of particles of a gas as well as the spaces between them is not fixed. So one particle may go there, it will come here, it may go there, like that. They have the position as well as the space between them is not fixed. Understanding? So that is the reason the particles of gas have the maximum movement. Understand? They can have highest kinetic energy. Highest kinetic energy, so that they can go anywhere in the large direction. Do you understand or not? Yes or no? At least that you can say, correct? So, due to this only, the gases have the most disorderly arrangement of particles. So, because of high kinetic energy, they don't have a fixed shape as well as they don't have a fixed volume. So, suppose you can take a small amount of gas, and you can fill, suppose, let me take 5 particles of gas, and I have kept it in this container. So the particles will be like this, like 5 particles of gas. I have taken little bit bigger container, and here also I keep the same 5 particles. Then also they will be occupied the full volume of this container. So that is why you can see the shape is not fixed as well as volume is also not fixed. But by applying pressure on these walls of the container, understand the pressure, understand, so we can compress them into a smaller area. Why? Because the spaces between them is more and more. Tamil Selvan, are you understanding? Spaces between them is more and more, so that we can easily compress. We can easily compress. So here, if you observe, the spaces between them is very, very larger, so that attraction is not present. Negligible attraction between the particles. So these particles always waiting at the walls of the containers. Whenever they will get a hole or else opening, immediately they will try to escape. That is why always we should keep it in a closed container, because they will exert the pressure. The pressure exerted by this gas is due to the collisions of fast moving particles. These particles are present very, very far each other, but they will move very fast. So if there is not, it is not opened, what will happen? They will collide each other very, very fastly, like accident. They will hit and they will hit and they will hit. So what will happen? These particles will come and will try to hit these walls of the container, because they want to come out. Understand? There is no force of attraction is present between them. So that is the reason when a gas is put in any big container, understand, it will quickly spread throughout the container and will fill it completely. Understand? Like one corner of your room, you will keep understanding that incense sticks, agarbatti, then the smell will come throughout the room, because very faster the gas particles will spread, because they have high kinetic energy. They are having very, very high kinetic energy, but least are negligible. Understand? Negligible what? Negligible what? Negligible intermolecular forces. Intermolecular forces. Do you understand, brothers?
Yes, sir.
That is the reason. So if the spaces are increasing, what will happen? Intermolecular forces will decreases or increases? The spaces are increasing.
Decreases.
All of you should remember, if the space between the particles is decreasing, please note it down. All of you, I will say the two statements, because still you are confusing. Manya and Samya, all of you note it down. If the space between the particles is decreasing, okay, like this you can write it. Solids, liquids, and gases. So now as we know that here, particles are what? Particles are closely packed. Is it yes or no? Closely packed. Understanding? So that, understanding, spaces are less. Least space is present between them. Is present, so that what will happen? Strong intermolecular forces. Strong intermolecular forces, as well as strong intermolecular forces. Forces is strong, so that kinetic energy how? Kinetic energy is least or most? Means maximum or minimum? Kinetic energy here. Particles are very closely packed. Distance is very small.
Least, sir.
So kinetic energy is minimum. Kinetic energy is minimum. Now, liquid loosely packed, not that much, loosely packed compared to the solids. So that spaces is little bit more, space is more than solids, So that understanding more medium intermolecular forces, so that kinetic energy is more than the solids are not. Space is little bit more, so that what will happen? Kinetic energy is more than solids. This is what about the liquids. Now coming to the gases. Gases what are? Very loosely packed. Very loosely packed means what? Maximum space present between them. Spaces are high, or else you can write like that. Space present between the particles is very high. Space is very high. So that if the space is very high, intermolecular force is what? Minimum or maximum? Intermolecular force. Intermolecular force. Spaces are very high.
Minimum, sir.
Negligible. Others you cannot. Negligible intermolecular forces. Negligible intermolecular forces. If intermolecular forces are negligible, what about the kinetic energy? You wait, Tamil Selvan Yusallu, Mavanesh, Manya and Samaya. Kinetic energy is maximum or minimum? Laksha. Kinetic energy. Nobody
Minimum,
is
sir.
kinetic energy is
Minimum.
what are you talking? Are you understanding or not? You tell me first, Manya. Here minimum I have written already. How it will come again minimum? The spaces is very more. Then kinetic energy is what? They can easily will free, easily can go. When you are in a traffic, is it possible to go very
Maximum, sir.
when you are in a traffic, is it possible to go fast, Manya? When you are in a free road, highway, where you will go very faster? Tell me, Manya. When your car is going along with the 10 cars, will you go with the fast speed, or else when your car is going alone, then you will go very fast? That is also no response. What I will do? So kinetic energy.
Sir, in highway, car will go fast.
Kinetic energy is maximum. Please note it down, all of you. Space is less. Space is less.
Sir, in liquids, kinetic energy, what, sir?
More than solids. More than solids. Understand? Suppose you see,
Okay,
you are
sir.
going in a streets, normal narrow roads. How you will go around? Space is very, very less. So you people will go slow or fast? Definitely will go slower. Yes or no? Because everything is very, very closer.
No, sir.
Very, very closer. So we should go very slow because we have less kinetic energy, like solids. Now, you are going in a normal single road, like one-way road. Then little bit, we have a little bit space. So we will go like liquid. We will go with the minimum speed. Next, if you go to the highway, particles are very, very far each other. Broad roads are there, very, very high national highways. Then what will happen? We will go with our maximum speed. Is it yes or no? Because why? Particles having a long area, very, very far each other, so that we can go very freely. Do you understand, Manya? At least now, Tamil Selvan? Write it. Is it completed, brothers? Tamil Selvan?
No, sir.
Do it fast. Alana? Hey, Mavanesh, what are you doing? Are you writing? Manya, do you understand or not now? Samaya, this is when is kinetic energy is maximum, when is kinetic energy is minimum. Solid particles are close, so that minimum kinetic energy. They cannot go freely. Gases, particles are very far each other. Here one particle, here one particle. So it can go like this fastly. It also can go fastly because they are not connected with anything. But here they are connected with the strong, very closely they are packed so that they cannot flow. That is what.
Okay, sir.
Always remember, space is increasing, kinetic energy is increasing. Space is decreasing, kinetic energy is decreasing. But if space is decreasing, force of attraction between them, strong bond will be present. If space is increasing, the bond will become easier, weaker. Now, for example, more better understanding you see. Suppose you and your sister hold each other like this. Now, I will try to separate you. Is it possible to separate easily? Manya? Is it possible to separate easily? Suppose Lakshya came and separated, trying to separate you. You people both hold like this. It is very difficult to separate. Yes or no?
Yes, sir.
Because you now strong attraction because you people are very close each other. Now, basically you hold your hands like this, like in the sense of like my hand, you hold your sister hand like this. Now, by pushing anyone, like liquid it is now, by pushing like Manya, you or Samya, she can easily separate you. Is it yes or no?
Yes, sir.
Yes, but same way, now you people are far each other, like fingers only holding. Two fingers are holding, like this. Now you people can be easily separate or not? Like this, you can easily separate. Why? Because now space between them you is more, so that she can easily remove you. Do you understand? Because of less intermolecular forces. Are you clear? That is what. So now this is all about the gases. So if you observe here, if it is completed, you please stop. Then, Lakshya, you understand or not, Lakshya?
Yes, sir.
So now if you see here, as we know that gases have no fixed shape as well as no fixed volume. So now, if it comes to here, understand, we'll explain a gas does not have a fixed shape because the positions of the particles are not fixed. Understand? So a gas does not have fixed position. Fixed position. Why? The particles have no fixed position. No fixed position for particles, as well as now no fixed volume also. Why there is no fixed volume means no fixed volume. So because if you observe here in liquids you see the spaces between them is equal. The spaces between them is equal so that their volume is always constant. But if it comes to the gas, this particle is this much. One more particle is here. One more particle is here. One more particle is here. We cannot say. So this distance is not equal. If you observe, the spaces between its particles is not fixed. Not fixed. Understand? So that only no fixed volume. Do you people understand or not? So that is the reason why the gases does not have, understand, fixed
Okay, sir.
as well as fixed volume. Understand? So now suppose if you see the particles of a gas, if you release them into this room, suppose your room, they can go anywhere, any direction, and they will occupy the shape and volume of our room. If you keep in any other container shape, because they are having a very least intermolecular forces, they can go to the any extent and they can always trying to live on the walls of the containers because they are exerting pressure. They are ready to escape outside easily. So that is why the spaces between them is more. So we easily compress them by applying pressure, like gas cylinder, how their large amount of gas is stored in a single cylinder because of compression. So we can easily compress them, compress it easily because the particles are very far each other, very far each other. Darun, are you understanding, Darun? Very far each other. So they have large spaces between them, large spaces between them. So which can be reduced by compression. So by applying pressure, this all the particles I can bring it into together. So that is only called as Understanding? Compression of gases. So these gases are compressed very, very easily. So now this is all about the compression. Now you tell me, liquids and solids is not possible to compress, but gases we can compress easily. Now, density now. Density. So density of the gases is less or more compared to the solids and liquids. As we know, solids is having more denser than liquids. Liquids is having less denser than solids. Compared to the gases. Gas, what is the density? Particles are very, very far each other. So what is happening? Volume is more. So volume is more means what? Density means what? Density is equals to mass by volume. So means density is inversely proportional to volume. If volume is more, density is less. So that now gases, tell me, what is the density? Least density or highest density? Gas having what density? Low density. Understand?
Low density.
Gas particles are very far each other. So they have very low density. Understand? They can occupy large volume. So that is why particles are very, very far each other. So that is the reason they have very, very low density. All of you should note it down. Gases has a very low density. Very low density. Understand, Amma? Yes or no? And these particles, they can move anywhere. Understanding? They can completely free to move anywhere. So that is why they can escape into the atmosphere when you release from the container very, very easy. So now you can see, to prove that a gas is having, there is no shape of, understanding, there is no shape, there is no fixed volume. So let us take now, all of you, observe how many of you know the balloons? How many of you know the balloons? We all people are fairly familiar with the balloons. Is it yes or no?
Yes, sir.
Now you observe. I have blown the air into a balloon which will come into spherical shape. Now it contains what? Air only. Is it yes or no? Air is a mixture of gases. Yes? Have time? I have
Yes, sir.
into this one. Now I can take one more balloon, understanding, which is having a shape of as some kind of a rod or cylinder shape, like this balloon I have taken. Now, the balloon will occupy, it will come to this shape also. Is it yes or no? Is it yes or no? The balloon will come to this shape also.
Yes, sir.
Yes, means in the sense of, is it having any kind of fixed shape? Is it having any fixed shape? No fixed shape. Is it yes or no? So both I have blown the air only. So here longer balloon and this is round balloon. So we can say that no fixed shape. Understand? No fixed shape. And as well as you can see, I have released even small amount of gas. It can be occupy the full balloon. Is it yes or no? Is it yes or no?
Yes, sir.
And you can see here, understand, we will find that they have different volumes also. This is a different volume and this is different volume. I have blown the same amount of air, but here occupying different volume and here occupying different volume. So we can say that from this, air is having, understanding, no fixed volume. Volume of air is not fixed. Volume of air is not fixed because the volume is varies. The distance between the particles is varies, so that we can say that a gas has no fixed volume and it will take the volume of what? Always it will take the volume of full container. Is it yes or not? So gas always will take the volume of container. Volume of container. If container is bigger, bigger volume. If container is smaller, smaller volume. So that is why we people can say that, understand, gases has no fixed volume and as well as no what? No fixed shape. Do you understand, Amma? Yes or no? All of you?
Yes, sir. Understood, sir.
So this is about to verify the fixed volume, and so there is no fixed volume and there is no fixed shape. Now, gases can be compressed easily. Is it true or not? Gases can be compressed easily. Is it true or not?
Yes, sir.
Yes. Now let us see. For that also we can perform the activity. Understanding. So let us take now some kind of a syringe. Do you know syringe? How many of you know syringe? Piston. Piston syringe.
Yes, sir. Yes, sir.
Injection the nurse, if you go hospital, she will give the injection. Now, let us see. Perform the activity. To perform this activity, we can see here. So now all of you observe this picture. So now first picture if you'll see here in this. Let it come. Yeah. Can you see this? Please tell me. You are not able to see, correct? 1 minute.
Yes, sir. It is coming, sir.
Yeah. Now you see. Can you able to see?
Yes, sir.
Now you see. So if we take here, I have taken totally 4 pistons. 4 pistons. Understand? Piston A, piston B, piston C, and piston D. Now if you observe, first piston I have taken common salt and solid. Common salt as a solid here. Understand? This is the solid I have taken. Now I am trying to apply from the top. Is it possible to compress? Is it possible to compress? I have taken a salt.
No, sir.
You can see the particles are very tight. Understand? Very closely packed so that it is not possible to compress it. They have very least spaces between them, so we cannot compress it. Now, second piston I have taken liquid. You can observe the liquid. So liquid, we cannot even compress it because they can take the only volume of that liquid. It cannot occupy the space of that full container. So here liquids also it is not possible to compress it. But third test tube, you can see. Third test tube contains water. Third test tube contains what? Gas.
Yes, sir. Yes.
Now if you press the piston, what will happen? These gas particles are come closer. Have you noticed it here? They have become very close. Means in the sense of we can
Yes, sir.
or not. We can easily compress or not. So that is the reason.
Yes, sir.
So gas can be compressed easily, but liquids and solids cannot be compressed. Do you understand, Samaya? Manya? It cannot be compressed. So with this experiment, we can prove that. Understand? So gases can be compressed easily, and liquids and solids it is not possible to compress. So that is why you can see gases have high compressibility. So if we take in our home, we have a metal cylinder contains a compressed cooking gas. Do you know that LPG, liquefied petroleum gas, which is present in our home, which has been compressed, highly compressibility, and it is a very huge mass, around I think 14 kgs of gas. It has been pressed or compressed in a small cylinder. Understand? Our cylinder weight, you may see that. Understanding 14 kgs of gas has been compressed. You can see, go and see in our kitchen, the weight has been net weight, gross weight, something they used to write. The gas which is present inside our cylinder is 14.1 minute. I will see how much it is. So actually, you can see if you have in the cylinder, net weight is 14.2 and the gross weight is around 20 kg. So this is cylinder weight. Minus if you do total weight is this is. If you remove this one, you will get the cylinder weight. So 14.2 kgs of gas is just compressed in a small cylinder. Understand? Do you know that if you release that gas, it can be occupied even complete Pudukkottai also. That much it can occupy. Understand, Amma? So that is the specialty of gas. Gas we can easily compress because of it is high compressibility. Because of its high compressibility, we can easily compress it. That is the meaning of it. Do you understand or not? Yes or no?
Yes, sir.
Yes. So this is all about the properties of solids, liquids, and gases. Is there any doubt? You please ask me. So if you'll understand this, then we will go for the next concept called as diffusion. Shall we start? I hope you understand well, correct? Laksha, you understand or not? Alana?
Understood, sir.
So now, Maunesh, shall we go for next concept, Darun? That is called as diffusion. All of you keep reading. The next concept called as diffusion. Shall we start now? Shall we start now? Now, you may notice it. Already I have taught you some experiment in the sense of inverted tube. One tube we can take air, one tube we can take bromine gas. Have you remembered that? Have you remembered that experiment? Please let me know. One tube I have taken air and one tube I have taken bromine vapor and I have mixed them, just inverted like this.
Yes,
Both-
sir. Yes, sir.
Yeah.
Yes, sir.
Same thing. Just consider the same experiment, real experiment as well as the imaginary experiment. Both I will show you. Just try to observe. So from that I will teach you what is diffusion. So now let us come to here. Try to understand all of you. So if you observe carefully in this picture, all of you observe. So first cylinder, if we take the first cylinder, it contains water. Read everybody, Tamil Selvan Mavanish. What is first containers? A colorless air. Is it yes or no? Any cylinder, empty cylinder, definitely it is filled with what? Air. So you can see here, air is a colorless. Now, down, bottom one we have a bromine vapor present in what color? Bromine vapor which is present in what color?
Brown color.
Brown color. Now, I have both inverted like this. Now, after certain time, you can see what will happen. The full cylinder, that both the cylinders will be turned into red-brown color. Do you understand? Do you understand or not? Here you can see upper cylinder is air. This is called as air. And bottom cylinder is a bromine gas which is present in red-brown color. Now, after certain time, if you leave them for the process, just you mix them, then after certain time, you can see it is completely turns into red-brown color. So why can't it is completely turns into colorless means? Air is a colorless substance, so we cannot see the colorless because air is also coming down. Here air also will coming down and will mix with the bromine gas, and bromine gas will go up and will mix with air. So equally they will diffuse. You understand? Both will mix equally, but we can able to see only bromine gas because it has some color, but air does not having color. So this process is only called as diffusion. So what is diffusion exactly means? Do you understand? So first beginning, let me come. In this cylinder, lower part who is there? Speak first. Lower part who is there? Lower part who is there?
Bromine gas, sir.
Upper
Bromine
part
gas.
who is there? Upper part who is there? Only air.
Are colorless.
Now, so both are different concentration. Means upper part air is more and lower part bromine gas is more. Is it yes or no? So now, what is the meaning of diffusion means? Both will be equally distributed. Understanding means one air and one bromine, one air and one bromine. Like that, this both will go from higher concentration to lower concentration. Means bromine gas will start flowing from lower to upper and air will start flowing from upper to lower because here air is more and here air is less, so that it will start coming downwards, and here bromine gas is more, here bromine gas is not there, so that the bromine gas will start going upwards. Like this, these will be exchanged downwards to upwards and upwards to downwards till it has been distributed equally. So once throughout both the cylinders, both will be equally distributed, then that movement won't be takes place. So this process is called as diffusion. What we should call? What we should call?
Diffusion.
Understand? So diffusion means spreading out and mixing of substance with another substance due to the motion of its particles. Means I am having one substance and Pradosh is having, or Tamil Selvan is having another substance. So just both we will mix them. So both they will mix each other. Understanding? Mixing of the spreading out of one substance with another substance due to the motion of its particles. That is only called as diffusion. Do you understand? So all of you write it. Diffusion. Do you understand, Amma? To bring equal concentration. That is the main reason. Nothing is there. Is it okay, da? Yes or no?
Yes, sir.
Now, why we are taking here, Darun? Why we are taking gases? Sir, why can't it solids? Sir, is it possible to mix the solids? Solids diffusion is very, very least. Liquids diffusion is a little bit faster. If you dissolve the solid in liquid, like sugar dissolved in water, then diffusion will be faster. Or else, if you take two gases, then diffusion is very, very faster because they have what? High kinetic energy. Do you notice it or not? Yes or no, Ra? So they have high kinetic energy, so that gases, the diffusion is much faster compared to the solids and liquids. Remember, solids, no diffusion will take place, but diffusion is very fastest in gases and slowest in solids because of highest kinetic energy. Write it, all of you. Diffusion. The spreading out and the spreading out and the spreading out and the spreading out and mixing of a substance, the spreading out and